SCADA is a blended discipline of information technology and operational technology. This translates the real world into a discrete series of events. While a good SCADA system can make a process better, a great SCADA system exposes the data to the rest of the business, paving the way for business intelligence, artificial intelligence, and the future. This is a cornerstone in our journey towards the fourth industrial revolution, involving smart manufacturing and the industrial Internet of Things. Most large-scale system designs are performed by groups of engineers organized by discipline. These groups have a sound understanding of each component of the system and how each component impacts other components of the same system. For this reason, it's unwise to hire more people to get a design done quicker. This is usually counterproductive. The SCADA development environment makes it possible to arrange information logically so that standards can be applied for maintaining each asset. Some platforms allow for programmers to develop directly to the requirements, encouraging linear development. There are other platforms that allow engineers to approach a problem laterally. However, there are few solutions that allow a systems integrator to produce a sustainable solution.
Standalone disconnected systems managed by SCADA engineers on networks hidden from companies' broader IT networks are a thing of the long gone past. These days, with the rapidly falling cost of Internet of Things devices, SCADA data is more than likely to be acquired from some cheap data logger on a public internet network. Couple this with the push for business intelligence integration and real-time reporting requirements, and the tsunami of cheaply available software as a service solutions means that the line between the control network is increasingly blurred. All this in the face of a heightened corporate stance on security means that the SCADA network is an increasingly complicated beast, and the scope for integration is vast.
SCADA systems are like building a house. The foundations are a solid design from well understood requirements. SCADA systems comprise of many different types of devices: PLCs, RTUs, DCSs, historians, comms networks, and a few other things like that. It's important to consider the whole of the system and design a system that will enable all of these to interact seamlessly together, whether it be a local or geographically dispersed system. SCADA systems can develop problems immediately or in the future. This can be due to poor requirement analysis and poor choices during the design. SCADA servers can be overloaded with connections. We often find historians can help with this. Poor data management and inappropriate protocol choices are one of these reasons as well. No consideration to system expansion, budget limitations affecting quality, and misuse perhaps by lack of training are some more of these issues. We at Parasyn have determined that the best form of SCADA project management is by an effective engineering handover of the client requirements. The engineers then clarify those requirements with the clients and develop a further detailed set of requirements, and then those requirements are agreed to the client. Following that, a strict design, then code, then test sequence is applied.
It helps for solution designers to have a wide perspective. Narrow product expertise has its place. However, concept designers and solution architects need to consider a much broader set of inputs. This isn't straightforward when products are changing every day. So how you put a team together and your approach to learning is really important to the success of building good solutions. Sure, producing design documents can make them stir crazy, but it pays off in the end. In practice, good design discipline builds confidence that it's built well.